Okay, think about this for a second. The phone in your hand, right now, it's probably the single biggest security risk to your company. But what if it was also the key to a technology that taps into, get this, a nine-dimensional reality? Sounds pretty wild, right? Well, let's dive in. We're going to connect the dots between corporate espionage, a brand new kind of antenna, and a theory of everything that might just change how you see, well, everything. So let's start with that device. The one that's probably in your pocket or on your desk as you're watching this. We all use our phones for work, right? It's just normal. But have you ever stopped to think that in doing so, we might have accidentally created the perfect corporate spy? A little back door for hackers to just waltz right into our company's most sensitive data? And the thing is, these threats are hiding in plain sight. You know that cool new app you downloaded? It could be siphoning off company data in the background. Or that urgent text from your bank asking you to reset your password? Yeah, that's called smishing. And we've all done it. Logged onto the free public Wi-Fi at a coffee shop or the airport. Every single time, you're potentially throwing the door wide open to your company's entire network. It's like a minefield, and we're just walking through it every single day. So what's really fascinating here is that all of these different threats, they all exploit the very same fundamental weakness. It's a concept called the last inch of the last mile. Think about it. We've got this incredible globe-spanning network of fiber optics and cell towers, but that last little bit, that final fragile connection from the network to the actual device in your hand, that's the Achilles heel. It's the weakest link where the entire chain can just completely fall apart. All right, so how in the world do you fix that last inch? Well, according to one group of inventors, you don't just patch up the old tech. No. You throw it out, you replace it with something from a completely different playbook, and they call it the Quantum Transceiver Antenna, or QTA for short. Okay, so here's where things get really different. A normal antenna, like in your phone, is kind of like a walkie-talkie. You can talk or you can listen. Push to talk, right? It can't really do both at once. But this QTA, they describe it as bisynchronous. That's a fancy way of saying it can send and receive huge amounts of data at the exact same time. Oh, and it also apparently works without a direct line of sight. So yeah, we're talking about a whole new ballgame here. Right, so the big question is, how does it actually work? The inventors have a really great way of explaining it. You know how a glass prism takes a single beam of plain white light and splits it into a perfect, beautiful rainbow? Well, they claim the QTA does basically the exact same thing, but for the messy, invisible chaos of radio waves all around us. And the secret sauce, what makes it all happen, is a proprietary technology they call antenna pixels. Just imagine a grid, a matrix of these tiny pixels, and together they create this electromagnetic ordering system. So it takes that chaotic jumble of radio signals that are flying all around us right now, and it just sorts them. It neatly separates them, concentrates each one with insane efficiency, and bam! That's how you get that powerful prism effect for radio waves. Okay, I know what you're thinking. That sounds incredible, in theory. But does it actually work in the real world? Do these claims hold up when you put them to the test? Can you actually measure the difference? At the end of the day, it's all about the data. And folks, this is where it gets really, really wild. So the source we're looking at presents data from an independent lab test. They put the QTA head-to-head with a standard Samsung phone antenna. So, at a key GSM frequency, the Samsung antenna clocked in with a signal strength of negative 81.6 dBm, and the QTA? It came in at negative 40.0 dBm, a huge difference. Now, I know what you're thinking. What do those numbers even mean? For anyone who isn't a signal engineer, that plus 41.6 decibel difference might not sound like much, but let me tell you, it is not a small improvement. The decibel scale is logarithmic, which means this is an absolutely astronomical leap in performance. To put it in perspective, this isn't the difference between a dim light and a slightly brighter one. This is the difference between a single candle and a giant searchlight. We are talking orders of magnitude more powerful. And when you have a performance jump that big, well, that's what allows them to make these just extraordinary claims. I mean, this is stuff that sounds like it's straight out of science fiction. They're talking about transmitting signals through solid rock and metal, operating without any conventional cell towers. Get this, even harvesting ambient radio energy right out of the air to power itself. It's just incredible. Which, of course, brings us to the ultimate question, right? How? How is any of this physically possible? And to even begin to answer that, we have to leave the world of engineering behind and dive deep into a radical new theory about the very fabric of reality itself. The CTO of the company actually offers a huge clue. He says, and I quote, "Only quantum systems are able to operate multidimensionally." So think about what he's suggesting there. He's saying this technology isn't just working better in our normal 3D world. No, he's saying it's tapping into other dimensions entirely. And that right there is the core idea behind something called the quantum synchronicity theory, developed by Stephen Fabitz. It basically asks us to just stop thinking of reality as just a bunch of physical stuff, atoms and molecules, and instead to imagine it as a massive, unbelievably complex operating system, one that's running on a hidden quantum code. So, according to this theory, our entire existence is a 9-dimensional structure. The best way to think about it is like those nested Russian dolls. So, step 1, the first 4 dimensions, that's our physical world. Easy enough. Point, line, volume, and time. Things we experience every day. But then, layered on top of that, you have step 2, these more abstract dimensions like scale and probability. And then, and here's the kicker, the theory claims there are 3 final computational layers in step 3, an actual OS that is running the whole show. Now, to back this up, the theory points to some really strange, real-world scientific puzzles. Take the genome complexity paradox. This is a weird one. Why is it that some really simple organisms, like certain plants, have genomes that are way, way larger and more complex than ours? From a purely biological point of view, it just doesn't make any sense. Okay, get ready for this, because here is the theory's absolutely mind-blowing solution. It suggests that DNA, it isn't just a biological blueprint for building a body. It's an ancient analog signal processor. Think of it like a quantum hard drive, one that's been accumulating data from these higher dimensions over cosmic timescales for eons. So from that perspective, a plant's gigantic genome might not be about its physical complexity at all. It might just be a sign that it's dimensionally older than we are. And just like that, this huge cosmic theory comes right back down to us, to you. Because if your DNA is actually a receiver for dimensional information, what on earth does that mean for your identity, for your consciousness? Well, this leads to one of the theory's most staggering conclusions, and that is, consciousness is not generated by the brain. Instead, it's a non-local field that exists everywhere all at once. And your brain? Your brain is just the exquisitely tuned quantum antenna that was built to receive it. There's a single line from the source material that just puts a perfect point on this whole thing. It suggests our DNA may encode, and I'm quoting here, metaphysical as well as biological information. Think about that. It's like the software for our consciousness passed down through the ages in our very genes. So that leaves us with one final, pretty provocative thought to chew on. If a piece of human technology, a new kind of antenna, can achieve seemingly impossible performance by tapping into these deeper principles, and if our own brains and our own DNA are basically doing the exact same thing, what happens when we finally learn to consciously read the code? What comes next?